Do a number of examples of matrix arithmetic. It'll be my aim to go quite quickly but clearly. So if you need to pause me or rewind me, do so. And hopefully if you rewind me, I will have been clear. Okay. So we've got two matrices here and we're asked to show that the transpose of A plus B is the same as the transpose of A plus the transpose of B. And this actually is to show that the transpose is actually a linear map itself. But yeah, so we're going to calculate the left-hand side first. So the first thing we're going to do is calculate A plus B. Now, thankfully, adding matrices is a piece of cake. So you just add them component-wise. So you're going to say add the 3 to the 3, the 1 to the -1, the 0 to the 5, the 4 to the 0, whatever squigglies you want to do for after that. So 3 plus 2 is 5. 1 minus 1 is 0. 0 plus 5 is 5. 4 plus 0 is 4. 2 plus -2 is 0. And 2 plus 1 is 3. Piece of cake. Now we're going to find the transpose of that. So we write that as A plus B transpose. Now remember, what the transpose does is it swaps the rows and columns. So this row, first row, will become the first column, and this second row will become the second column. So the first row, 505, becomes the first column. And you can do this, by the way, with columns to rows, you get the same thing. 505. And the second row, 403, becomes the second column, 403. And just to be absolutely clear in what we're doing, the first row became the first column and the second row became the second column. Okay, so we want to show that this is the same as A transpose plus B transpose. So now separately we should find the transposes of A and B. What we could do, I suppose, is write them like this. A transpose plus B transpose is equal to. So doing the same with A and B separately. So now we added and then transpose. Now we're going to transpose and then add. So A is, first row is 310. If I do the transpose of A, that becomes the first column, 310. The second row, 422, becomes the second column, 422. So that's the transpose of A. Plus the transpose of B. First row, 2 minus 1, 5, becomes the first column, 2 minus 1, 5. And the second row, 0 minus 2, 1, becomes the second column. And then we just add these together and add them component-wise. So the 3 plus the 2 gives us 5. The 4 plus the 0 gives us 4. The 1 plus the -1 gives us 0. The 2 plus the -2 gives us 0. The 0 plus the 5 gives us 5. The 2 plus the 1 gives us 3. And note, that is exactly the same as A plus B all transpose. So we have done what we were asked to do. Mighty. And those things will always be equal. A plus B all transpose will always be equal to the transpose of A plus transpose of B. Right. Question here. I'm just going to look for space. Yeah, this is to be done down here. Okay, there's nothing special about square brackets versus round brackets. So to multiply A by B, we'll look at the sizes. So the size of A has 3 rows, 1, 2, 3, and 2 columns, so it's 3 by 2. And B is 2 by 2. Now what we might comment is that you can multiply A by B because these middle numbers match, and the matrix we get out is size 3 by 2. Okay, you couldn't do B by A, and I would recommend, if you were asked to do B by A and you could do B by A, that you write out the matrices again, because it's going to be hard to multiply rows of B by columns of A. But here, thankfully, it's A by B, so it's rows of A by columns of B. So we're going to get out a 3 by 2 matrix. So let us set that up. 3 rows. Now I can switch to square brackets, it doesn't matter. So that's supposed to be 3 rows. and then 2 columns. Now, I'm going to write in something here in light blue, but I don't recommend that you write in because I'm going to scrub it out. So what we're going to do here is, so see this cell? This is in row of this new matrix. This is row 1, column 1. So how we find this is we're going to do the dot product of row 1 in A by column 1 in B. This one here is row 1 by column 2 because it's in the first row of this new cell thing and it's in the second column. So we're going to multiply the first row of A by the second column of B. This is now the second row. We'll do all these. So here's second row, and down the bottom this is the third row. And then look at this. This is first column, and over here second column. So I'm saying don't write those in. I'm going to rub all those out. So this is what all the entries are going to be. And I'm going to do this fairly quickly. So you might want to pause and check what I'm doing. So top left hand corner, first row, first column, 1 by 5 is 5, plus 8 by minus 2 is minus 16. Hopefully I don't make a mistake. Next one over, row 1, column 2, 1 by 9 is 9, plus 8 by 7 is 56. Next one down, row 2, column 1, 3 by 5 is 15, minus 2 by minus 2 is plus 4. Next one over, row 2, column 2, 3 by 9 is 27, plus minus 2 by 4 is minus 14. Down the bottom, row 3, column 1, 0 by 5 is 0, plus 4 by minus 2 is minus 8. And the other one that's left is row 3, column 2, 0 by 9 is 0, plus 4 by 7 is 28. And then we'll tidy this up. 5 minus 16, I suppose, is minus 11. 9 plus 56 is 65. Now, I might make small arithmetic errors here, and you can comment to them if you want. You can send me an email, is what I'm saying. There we go. Done. Multiplication. Next page. So we've got two matrices and calculate these things, 2a plus b. Now, let's just write down what 2a is before we do 2a plus b. Now, we don't really have to find 2a, but no, we'll leave it in the next thing. Oh, it's here, handy. So 2a, you multiply everything by 2. So the like the 5 gets multiplied by 2, the minus 3 gets multiplied by 2, the minus everything in a gets multiplied by 2. So I'm looking at this here. Now look at the size of 2a. It's 3 rows, 2 columns. But b is 2 rows and 3 columns. Now you can multiply them together either way, but you cannot add them. You cannot add 2a, which is a 3 by 2, plus b, which is a 2 by 3. So this is undefined. To add, you can multiply, cannot add. So it's written here, 2a is the same size as a, but 2a plus b is not defined because the matrices are different sizes. So the answer is basically just not defined. Okay. What about question B? So 2a plus b transpose. Yeah, so there's a small comment here. So you do the transposing before the adding. That's according to BEMDAS essentially. So we found 2a, so we will work with that. And then b transpose. So 2a is written here. I'll go back to the roundies, doesn't matter, same thing. And now b transpose. So with b transpose, I'm swapping the rows and columns. So I'll just look at this one. This row will become the first column. This row will become the second column. So we're talking plus. So the first row, 1 minus 2, 3, becomes the first column. And the second row, minus 3, 0, 2, becomes the second column. And then we've loads of space to add these together. So just add component wise. So 10 plus 1 is 11. Minus 6 minus 3 is minus 9. minus 4 minus 2 is minus 6, minus 8 plus 0 is minus 8, 4 plus 3 is 7, and 0 plus 2 is 2. Okay, that's that. And then the last one is b by a. So this is an example where I actually recommend writing out the full matrix again, because it's hard otherwise working right to left. Okay, so I'm going to write out BA down the bottom here. So BA equal to, so yeah, I'm going to have to do this to write very small. B 1 minus 2 3 minus 3 0 2. Now write A 5 minus 3 minus 2 minus 4 2 0. Imagine kind of having to do that with the other way around. That's a nightmare. So we should look at the sizes. So B is 2 rows 3 columns, and A is 3 rows 2 columns. The middle numbers do match, so we can multiply these together, and we're going to get out a 2 by 2. So let's set up our 2 by 2 matrix. 2 rows, 2 columns. Now hopefully at this stage you can understand what's going on. So I'm going to go through the top left hand corner first. This one, then I'm going to do this one, then I'm going to do this one, and then I'm going to do this one. So this one is row 1, column 1. So I'm going to multiply row 1 by column 1. So row 1 by column 1, I get 1 by 5 is 5, plus minus 2 by minus 2 is plus 4, plus 3 by 2 is 6. Now I'm moving over to the right, which is still row 1 but column 2. So I'm going to multiply row 1 of B by column 2 of A. So I get 1 by minus 3 is minus 3, minus 2 by minus 4 is plus 8, 3 by 0 is 0. Now I'm going down the bottom left corner. Now that's row 2, column 1. So I'm going to do row 2 of B by column 1 of A. So minus 3 by 5 is minus 15, plus 0 by minus 2 is 0, plus 2 by 2 is 4. And then the bottom right is second row, second column. So multiply second row by second column. Minus 3 by minus 3 is plus 9. 0 by minus 4 is plus 0. Plus 2 by 0 is 0 as well. And therefore we get 15. Minus 3 plus 8 is 5. Minus 15 plus 4 is minus 11 and 9. Now again, if it's fast, you pause and rewind. We're getting the 3 hours into less than 2 hours to give you that chance. Okay, now this one, what I want you to do is try it yourself. So basically in a moment I'm going to ask you to pause it and try to do this yourself, and you can write in here, and then when you unpause I'm going to go through it very quickly. Okay, so pause the video and try it yourself. Okay, we're back. So A plus C, well, can we add these together? Basically just no. A plus C is undefined. Because they're different sizes. It just does not make sense. Second thing, A by C. So I've written the A by C together. So I'm going to analyze the sizes. So this is 2 by 3. And this is 3 by 2, 3 rows, 2 columns. I can see those middle numbers matching. So I can multiply these together. And what I'm going to get out is a 2 by 2. So I'm going to set up a 2 by 2 matrix for myself. 2 rows, 2 columns, and now I probably could have made the cells bigger, but anyway. So then I'm going to do the rows by columns as appropriate. So in the top left corner, it's going to be 2 by 5 is 10, plus 1 by 2 is 2, plus 0 by 3 is 0. The next one is row 1, column 2. 2 by 3 is 6, plus 1 by minus 1 is minus 1, plus 0 by 4 is 0. Down the bottom is row 2, column 1. So it's going to be 3 by 5 is 15, plus minus 2 by 2 is minus 4, plus minus 1 by 3 is minus 3. And now down the bottom, it's going to be row 2, column 2. 3 by 3 is 9. Plus minus 2 by minus 1 is plus 2. And then minus 1 by 4 is minus 4. And then I'm going to tidy this up. 10 plus 2 is 12. 6 minus 1 is 5. 15 minus 4 minus 3 is 8. And then 9 plus 2 is 11. Minus 4 is 7. So check that against your work. And then we've got a nasty one here, C by A. Let's look at the sizes. Now there's a comment that, so there's just so many different ways that the order of multiplication matters. We've seen that sometimes you can multiply one matrix by another, A by B, but not B by A. You can have two square matrices, which we'll see, where you can do A by B and B by A, but they're different. And here we can do A by C and C by A, and not only are they different, they're different sizes, they're completely different beasts. 2 by 2, and so we're ending up with a 3 by 3. So I'm going to need a big cell out, a big 3 by 3. Row 1, row 2, and the bottom is row 3. Column 1, column 2, and the last one is column 3. And I'm multiplying rows by columns. So starting at the top, row 1, column 1, 5 by 2 is 10, plus 3 by 3 is 9. Now maybe I'll just do this next one slowly. So this next one, you see you're in the first row of this celled up thing. So it's row 1. And it's in the second column of this celled up thing, column 2. Now let me show you what I mean here. See this cell? Row, oh crap. I thought I had a different thing altogether there, sorry. There's a highlighter. Let me give it a bash. Row 1, column 2. Okay, so that's what I'm talking about. What's my old pen? Oh no. I think this is the right one. Okay, so row 2 by column 2. So it'll be, and it's row 2 here. Sorry, row 1 here by column 2 here. So 5 by 3 is 5, plus 3 by minus 2 is minus 6. And the last one, 5 by 0, 0, plus 3 by minus 1 is minus 3. Down over here, I'm looking at row 2, column 1. 2 by 2 is 4, plus minus 1 by 3 is minus 3. The middle one then is 2 by 1 is 2, plus minus 1 by minus 2 is plus 2. And the last one over is 2 by 0, 0, minus 1 by minus 1 is 1. Bottom left-hand corner is row 3 by column 1. 3 by 2 is 6, plus 4 by 3 is 12. And then the next one over, I'm looking at row 3, column 2. 3 by 1 is 3, plus 4 by minus 2 is minus 8. And then finally, the very, very bottom right-hand corner is row 3, column 3. 3 by 0, 0, plus 4 by that is that. And then I should tidy this yoke up. So 10 plus 9 is 19. 5 minus 6 is minus 1. 0 minus 3 is minus 3. 4 minus 3 is 1. 2 plus 2 is 4. 0 plus 1 is 1. 6 plus 12 is 18. 3 minus 8 is minus 5. And I have a minus 4 there as well. Okay. And we're going to look at one more example, I think. Yeah. So here we go. So if you want at this stage, you could pause it and try and go ahead. That'd be fantastic for you, really. So we're going to look at the left-hand side. So the first thing we should do is calculate BC. Now B and C are written in that order, so I don't have to write them out again. I do, if I'm multiplying them, have to analyze the sizes. This is a 2 by 3. This is a 3 by 3. I can multiply them together. And I end up with a 2 by 3. Okay, so BC is a 2 by 3 matrix. So this will have 2 rows and then 3 columns. Hopefully that's plenty space. And I'm going to go, look, as usual, quite fast through it. Hopefully you can kind of get it. I mean, it has been done slower at different stages. We'll just do a random one there. So say this one here. So where they cross, what row is this? This is, change the pen. This is, you're in row 2 here. Excuse me, that's wrong. Row 2, column 2. So you do the dot product of row 2 from B and C2 from C. So dot product of row 2 with column 2. Dot product. And in terms of what order do you multiply along the row? This way along the row, this way along the column. So down in this one, it'll be 3 by 0 is 0, plus minus 2 by 0 is 0, plus 4 by 5. So hopefully you get it by now. And just do that for all of them. So the top left-hand corner is row 1, column 1. So you get 2 by 1 is 2, 1 by minus 2 is minus 2, minus 3 by 4 is minus 12. The next one is same row, but second column, 2 by 0 is 0, plus 1 by 0 is 0, minus 3 by 5 is minus 15. And then the last one over there is same row, last column, 2 by 3 is 6, plus 1 by 2 is 2, plus minus 3 by minus 3 is plus 9. Bottom left corner is row 2, column 1, 3 by 1 is 3, minus 2 by minus 2 is plus 4, plus 4 by 4 is 16. We've done the next one, and then the bottom right is row 2, column 3. So 3 by 3 is 9, plus minus 2 by 2 is minus 4, plus 4 by minus 3 is minus 12. And we can tidy that up. They have space here. 2 minus 2 is 0, minus 12 is minus 12. The next one is minus 15. Next one is 6 plus 2 is 8, plus 9 is 17. The other one is 23. Next one is 20. And the last one there is, say, 9 minus 4 is 5. Take away 12 is minus 7, I suppose. Yeah. Okay, so that's BC. Now we want to find the transpose of that. So the first row becomes the first column. So therefore, BC transpose equals first row becomes first column. Second row becomes second column. Right, now what we want to show is that this is the same as C transpose by B transpose. So if I want to multiply C transpose by, I definitely need to write them out. On the one hand, because it's a C by a B, but also because they're transposed. Okay, so let's write this out. So C transpose B transpose equal to. Now remember, the transpose just swaps rows and columns, and the way you do this, first row becomes first column, second row becomes second column, third row becomes third column. So for C, the first row is 103, becomes the first column. Second is minus 202, becomes second column. And last is 4, 5 minus 3, goes like that. And then for B, first row is 2, 1 minus 3, becomes the first column, 2, 1 minus 3. Second row, which is 3 minus 2, 4, works like that. And now we need to multiply these together, and we must get the same answer, or otherwise, well, we'll get the same answer, hopefully. 3 by 3, 3 by 2. We can multiply these together, because these numbers match. Suppose the thing about the order changing from BC all transpose to C transpose B transpose, you wouldn't be able to multiply. You wouldn't even be able to multiply B transpose by C transpose. So that certainly couldn't be it. So you get this weird changing of order. Okay, so we get a 3 by 2. So let's cell this up. 3 rows. 1, 2, and the bottom is 3, and 2 columns. Not sure, is that really enough space? It's not, but look. Sure, we'll drive on. So up the top left, row 1, column 1. 1 by 2 is 2, plus minus 2 by 1 is minus 2, plus 4 by minus 3 is minus 12. Next one over is row 1, column 2. 1 by 3 is 3, minus 2 by minus 2 is plus 4, plus 4 by 4 is 16. Then moving on to the next row, first one is row 2, column 1. So it's 0 by 2 plus 0 by 1 plus 5 by minus 3. Then the next one over, same row, row 2 by column 2. 0 by 3 plus 0 by minus 2 plus 5 by 4 is 20. Now down the bottom here, we're into row 3, column 1. 3 by 2 is 6, plus 2 by 1 is 2, plus minus 3 by minus 3 is plus 9. And finally, row 3, column 2, 3 by 3 is 9, plus 2 by minus 2 is minus 4, plus minus 3 by 4 is minus 12. And now let's tidy that up. 2 minus 2 minus 12 is minus 12. 3 plus 4 is 7, plus 16 is 23. We've got a minus 15, we've got a 20, we've got a 17, and 9 minus 4 is 5, minus 12 is minus 7. Now, are is this the same? Yeah. Here is your BC all transpose, and this is equal to BC all transpose as required. That's what the question was looking for, show this. So there's your examples of matrix arithmetic. There's a few others. There's a small little, if the matrix multiplication is really confusing you, here's a possibility for you. So like say the 11 here, right? So you do multiply this row by this column. 2 by 3 is 6, plus 3 by 2 is 6, plus 6 is 12, and then minus 1 by 1 is minus 1. You get the 11. It's a possibility. I'll just do all the colors. Then the next one is this one by this one gives you this one. Then say the oranges, this one by this one gives you this one, and then one more purple. This one by this one gives you this one. Yeah, okay.